battery management system. This is getting to be a hot topic nowadays because of the EV, electric vehicle, and also there are many other places where the battery is used. And whenever you have rechargeable battery, you need to have electronics which is called battery management system, BMS. Okay. And this BMS is getting hot topics because there are many different type of batteries coming out in the market. The one is a sodium battery, which is different from lithium battery, and also solid state battery, which has higher energy density, and it's basically lithium with some other rare earth materials, and performance is excellent with less explosive. Each battery has a different characteristic, and depend on the characteristic, the electronic system has to be recreated. The BMS is for the battery type. You have to adjust. Here we talk about the general electronics design. The typically energy source is the AC, but some of rooftop solar cell on the parking lot save up the energy in the battery already and use that battery to charge the EV. So that's the source will be the DC. But whichever the source, energy source, you need to have energy source and create DC. And here you need to have control to make the output, and this low pass and low pass filter. We talk about this in the previous video. You have to look at this. So this is going to be output, and that goes to the charge, battery charge. And what is this is you have chopper, and another one is called duty cycle control. Duty cycle. And duty cycle control come from here. So what it's doing is when you have a DC of 50 volts, it's chopped up into square AC, and this square AC depend on duty cycle. After you go through the low pass filters, it can be average output, can be like a 10 volts to 40 volt range, and this duty cycle decided. When duty cycle become like this, then positive time is smaller, so average decrease, and we can demonstrate in the hand-on electronics later. When duty cycle is large, then positive period become large. That means output goes higher than average 25 volt. The 50% duty cycle. You know how to adjust this duty cycle. I think we already talked about use a CR constant, and when it goes to say this is the final output and 1/2, then comparator switch and control this high power MOSFET and turn on and off according to the duty cycle control. And who control the duty cycle? this output voltage is measured, right? Of course, you need the AD converter, and you have a target voltage. This is a target voltage, and this is a measured voltage. And now you compare, then you know which way to adjust, increase or decrease duty cycle. So here's a loop back system. So output is measured. Okay. Now, measuring output voltage is not good enough. This is an intermediate BMS system. The crude one is it doesn't even measure set the output voltage, certain voltage, fixed voltage, and charge it. This is low end BMS, and this is intermediate. So high end battery charger, what they do is it's also measure the current, and the reason is to establish the battery's maximum voltage and do not overcharge. This current measurement is Coulomb counting. It means you count how much Coulomb pass through this monitoring before you declare it's fully charged. Okay, so high end have several things you have to consider. Number one, avoid overcharge. So what happened, the 12 volt batteries, if you keep giving 15 volt all the time, the internal resistors goes up and reduce the current, but over the time, if you leave it long time, current keep going beyond the specified 12 volt battery, right? And that's called overcharge. Overcharge means it's called internal chemical reaction beyond the reversible, beyond the reversible range. It's become irreversible. Means like a cell phone, overcharged cell phone. You look at from side, it's bulged up like that. Okay, that means the chemical produced the gas, and this irreversible change. This is the overcharge problem. And the second, the high-end BMS monitor temperature. And of course, monitoring temperature, you need AD converter and CPU decide to slow down the charging or not, especially when you have a high-speed charging. This is important because some system is not up to high-speed charging, and by doing a high-speed charging, it's go beyond the specification of the battery, and it's going to heat up and explode. So the monitor temperature is very important. Third, avoid catastrophe. What kind of catastrophe is like short circuit, suddenly the current increase. So that's another reason why you have to monitor the current. It's you're charging at 10 amp, like a 10 amp per second, and suddenly goes 20 amp per second, something wrong, maybe or short circuit or something, or battery punctured or some catastrophe happened. So this kind of output protection must have the electronics, that means IC chip. So output, this is a BMS IC chip. The monitoring output voltage is one thing. We have to monitor charging current or monitor temperature. And charging current, there are twofold. Overcharging, like 10 amp is maximum, is suddenly increase, something happened to the battery, okay? And another one is the over max battery voltage. Now this is a very difficult problem because battery maximum voltage is different from battery to battery, and also even the same type of battery is slightly different. So suppose one battery 12.2 volt is going to be pretty much max out, and you keep giving 12.5 volt, and there is a 0.3 volt. 0.3 volt keep sending the charge, the coulombs, right? And battery accumulate, and that much it's going to cause irreversible change. So how you establish maximum voltage? Okay, battery characteristic is like this. Maximum voltage, when you use this discharge, it's drop, right? And it stay for a while and suddenly start dropping again. So this is a stable period, and this is a max voltage. So what's happened is, ideally the charging profile is going to be that you monitor how much charge current going to the battery system, and this become less and less. It's drop 10 amp to 1 amp, and now you have to start reducing the output voltage at this point, but still going 100 milliamp charging and reducing even voltage more. Say this is 12.25 volt, and the output voltage 12.2530 is adjusting to very close to this voltage. Then it's become like 1 milliamp and microamp, and which point you declare this is fully charged. So you need to have some decision making. The CPU has to decide, okay, it's dropped to 1 milliamp, so we declare it's fully charged. And what do you do when it's fully charged? You drop the charging voltage slightly less than the battery voltage. Okay, so the current is going to reverse back. Okay, so it's completely shut off this current. It's cut off to 0 amp. Okay, so this is the ideal charging profile. Now high speed charging, we start even higher, 20 amp, and drop to 10 amp and 1 amp. So rather than voltage, charging voltage dictate, charging current dictate the charging profile. So charging current monitoring is very important. But as you know, the current monitoring wastes power. So typically we use very low voltage like 0.1 ohm and even 20 amp, right? Its drop is what, 0.2 volt. So the power wasted here is going to be Ri square, right? 0.01 times 20 square watt. Okay, so we're talking about 0.2 when you are charging 20 amp. When it's go down to 2 amp, then we're talking about voltage here is 20 millivolt. And when it's dropped to say 0.2 amp, then you're talking about 2 millivolt. So extremely low voltage we have to detect. And the AD converter cannot handle this low voltage, low voltage. I'm sorry, low voltage. The probably reliable range is 5 millivolt. Okay, so what do? You need a special current detection, very small current, the very small current, but it can be 20 amp in the beginning, so we need a protection for this, and also very small current sensor. So how do you make this sensor? And this sensor design is like each company use different method, and now it's a proprietary. And I have one design, but instead of revealing complete circuit diagram, I will say monitor small voltage and amplify it, and set cut off point, and CPU use this cutoff point. That means whenever it's reached to this low amp, like okay, only 0.2 amp going, and we declare it's fully charged, we cut it off, then drop the charger voltage by say 200 millivolt. So what's happened is battery is slightly higher voltage than charger. Okay, and that's a way from here current becomes zero. This is a way to avoid overcharging. Okay, so this is a high-end BMS. The usually you have those USB charger, this is a low end. It just set the charging voltage to 12.5 or so, and if you keep connecting this to cell phone battery may overcharge and damaged, unless some of high-end cell phone like Samsung's, they have internal circuit to avoid that overcharging. So that's what is going on in the industry. This low cost is like couple dollar USB charger. Doesn't have a full feature of BMS, but you need to have it when you have like a large battery pack charging from solar cell on the top of the parking lot, or you have a professional energy center where you save energy. You need to have it, otherwise the battery life is going to be shorter, and it's going to cost even more. So that's the BMS. I hope you enjoyed today's video. If you think you can get something out of this video, please subscribe. Let's look at some demonstration in the hand-on electronics. Okay, hand-on electronics right now. The pulse generator duty cycle 50% and 1000 hertz. Okay, and they show the pulse coming out. And right now duty cycle 50%. If you measure this voltage, this voltmeter, let's see here, voltmeter shows the average, right? 2.4. Now we change the duty cycle. Let's see. Okay, duty cycle we reduce. Here you go. Drop to 1 volt. Increase the duty cycle. You see this one. The pulse positive side become bigger. 3.1, 4.2 volt. Okay, because this guy voltmeter take this pulse and shows the average voltage. So right now duty cycle is exact 50%. You see, exact 50% and 2.45, because this pulse coming out from this guy is not exactly 5 volt, it's slightly less, so it's a half of the voltage. So that's how the charger output voltage is adjusted. The change duty cycle before going to the low pass filter, which this guy has, and increase the duty cycle to increase the charging voltage. Okay, so if you use this unit as a voltage charger, then by adjusting the duty cycle you can easily change average output, because after low pass filter what you get is average voltage. So this average voltage 2.4 right now, because 5 volt 50% duty cycle. Okay.